All right, so we are ready for some more bite-sized Python. We're going to take a look at, even though the PowerPoint title screen says for loops and while loops, we're going to look specifically right now at for loops. In an effort to keep this video under 20 minutes, let's shoot for 15 minutes. What do you say about that? We are going to take a very granular look at for loops. We'll go broader and then we'll work our way inward. So let's get started without further ado. All right, so today on the docket, we're going to be looking at for loops. Forget while loops, I know it's on there, but we're going to skip that for now. We're going to look at adding a couple of more pieces to our kit, some more arsenal for our coding experience. Here we're going to look at the keyword break and the keyword continue. But we really want to focus on this structure that we call a for loop. It is the first of our iterators, our looping mechanisms, and you're going to see why it's called a looping mechanism very shortly. And that's what we're going to put our intentions towards today. All right, so what's a for loop and why the heck will we need to use one? Great questions. Let's answer those. So a for loop is used generally just to iterate over a collection or a sequence. It's to look at a collection, which we're already familiar with, and go over that collection and do something. Why would we want to do that? Well, because looping over collection is important if we want to do something specifically to each item in a list. You know, we've reviewed comparison operators, we've talked about logical operators, but frequently we have to do these things not just in piecemeal or onesies, twosies. We need to do them over vast collections, usually containing many, many elements. And if there's one thing that computers do and do well, it's monotony and repetition. Thus, the for loop. You're going to find for loop in every programming language. It's one of the most fundamental logical structures. The idea of going over a process multiple times until a condition is met or until we've reached the end of a collection list. Now, in this case, we're going to go specifically until the end of a collection. Our whole goal is to have something that we do, and we want to do it each and every time to an item, or at least consider each item in a collection as we do it. So let's take a look at the for loop, and don't get freaked out if you don't understand this. We're going to get into the anatomy of a for loop pretty soon here, but I just want you to see it. I want you to see the construct. So first thing, when we're talking about going over a collection, we actually need to have a collection. So that's what I did here. We've got a list, and we're going to name this list pets. We got our pig bacon, we got our chicken named Nuggets, we've got another chickadee named Omelet, and we've got our lamb that we call Chops. So what we want to do is we just want to print out all the names of our pets. And that's what we're doing here in this process. And this is exactly what the for loop construct is. The keyword for, which it tells the interpreter, get ready, right? Pet in pets. We've got an indentation suite, and we're going to print pets. That's the mechanism that we're going to do. Let's take a look at this in detail, but first I want you to observe that everything we do is going to, every part of this mechanism is going to go and touch each element from element 0 to the last element, element -1, or in this case, element 3. So all 4 elements. Let's dig into the anatomy and see what we're working with. Here is our for loop. If you've never seen this before, it might look a little intimidating, but don't let that freak you out. Let's take it step by step, symbol by symbol, word by word. First, we've got the keyword for. You can see that our IDE does a great job of highlighting this, letting us know that it's something important. But more importantly, it's letting us know that the interpreter sees this as something important. This is the start of a logical mechanism for the interpreter. At this point, the interpreter, the Python interpreter says, okay, I see the keyword for. I need to align a set of rules and syntax to let me know that I'm going to tell the developer if they're on the right track or if they're off the wrong track. He or she is doing the right thing or not. And that's what the for word is. It's a keyword. It's that starting point for the interpreter. Now the next word we call a sentry. Now the sentry can be any word that you want it to be. Typically, it's usually just the letter I if you're doing a quick for loop, and that's short for iteration or iterator. And it's something's happening when you put this sequence of words. So for starts the mechanism. The interpreter knows we're getting into a for loop. The next thing that I'm expecting as the interpreter is the century. It's basically creating. It's not basically. It is creating a temporary use variable, and that variable is actually going to hold the value as we start from the first element and iterate through all of the elements. Now, the next one, the next word or symbol that we have in this construct is the keyword in. You can see it's also highlighted a different color. It's because it has special meaning for our interpreter. Now, in has two purposes. The in is used to check if a value is present in a sequence, like a list, a range, a string, etc. But in this case, the in keyword is also used to iterate through a sequence in a loop, right? So we're looking at all of the things within a collection. And that collection we actually identify with this last word, this last symbol in the construct. This is the collection variable name, right? In this past scenario where we're talking about our pets, we named the list pets, and therefore that's exactly what we're doing. We are looking for this element in this collection, right? This tells us our for loop, our interpreter point towards this collection. This is what we're going to be iterating over. And then of course we have our colon here, which means it's a symbol that indicates we are going to be in an indentation suite. Everything that is indented from this root left margin here is now only going to take place while we are looping in the for, well, while we're within the for loop. And essentially, what we can do is we can put as many commands, mechanisms, any operators or operations that we want to happen inside this indentation suite, and they will happen in the order that we put them for each and every element, starting from element 0 all the way to the end of the collection. The indentation suite contains the statements to be performed on whatever the century is pointing to. If you don't get that, go back a couple seconds and think about this. This indentation suite indicates that these statements are going to be performed on whatever the century is pointing to. And the century will point starting at the first element and go through each statement all the way to the end and then pop back up, and then the century will point to the next element. I hope that makes sense to you. If it doesn't, don't worry. When you see it in action, it's gonna be a little more apparent. But I want to give you kind of an understanding of the anatomy of a for loop. And there's our statement. Okay, so really quickly, there are also other uses for the for loop. If you recall, I think this was back in week 2, we talked about how strings were very unique because they could be considered collections. Well, guess what? We can have some fun with just a string. If you want to perform an operation on every element, i.e. every letter of a string, you can do that. In this scenario, we are creating a variable letter to hold the place that we're focusing on for each letter in word, this variable right here. I want you to print the letter. And sure enough, it will line by line print each letter. So I want you to think about how the interpreter, how Python as a programming language treats collections. And as we know, a string is a collection. So therefore, ergo, this is fair game for a for loop. All right, let's kick some code. It's about high time for that. All right, let's go back to our original for loop. We have our pets here. Let me turn on a REPL. For each pet, each sentry, each item of focus, element of focus in our collection, which is pets, I'm simply going to print that pet, print the focus. All right, so here we go. You'll note in the order, bacon, nuggets, omelet, chops. In the order of the list, bacon, nuggets, omelet, chops. That's simple. Now, as always, in the Canvas shell, you can follow along with any of these examples to try them out, modify them, play with them, do something crazy with them. Feel free. Here's the file list right here. But let's try something else, something a little different. So the real meat and potatoes of a for loop is we typically want to use logic on each item or on items. And that that logic, that comparison, that evaluation is based on criteria. So let's think about a problem that we need to solve or something that we're doing. And here's a good one. Let's look at this line by line. I want you to note the double indentation. That means we actually have two logical constructs, mechanisms going on here. But I want you to think about this. What is this loop doing? And what statements will be run and when? And what are we going to get out of this? Take a second, pause the video, look at what's going on here, and then think logically, item by item, what you think is happening and what you think the output will be. All right, I hope that gave you some time to consider, to ponder, to do some self-reflection in your Uber developer psyche and come up with a solution. But it doesn't matter because we're going to go through this together. Let's take a look line by line as the interpreter would from top to bottom, left to right. Let's see what's going on. Well, first things first, we've got some comments. You know, we are not going to process these comments, but it's saying before running this script, think logically. What is this for loop doing? We're going to figure that out. All right, let's skip down to our next readable line. Well, we are creating a variable. We've got an assignment operator in the equal symbol, and we are creating a list. In fact, we're creating a collection. And the data type for all of these items is a number. And we've just got a list of seemingly random numbers. Okay, so that's what we got so far as the interpreter. We've got a variable named nums, and it's a list, it's a collection of random numbers all over the place. Now, as we're using our interpreter brain, we're going down and boom, we see a for, a keyword. It's in purple. Something's going on. Let's see. For I, so this is our sentry. We know this is going to take the place of each element that we're looking at in a for loop. For I, so we're creating our sentry in nums. We know nums is a list, right? A collection of numbers. And then we have our indentation suite. Now let's drop down. So now whatever happens in this margin, this space, is going to be looped over for each item in the list. And what's going on? If I, so let's think. Let's go back up, sorry. For, all right, I in nums. Instantly that points to the first element, which would be the number 12. So we can just replace all of our i's with the number 12. If 12 modulus 2 is equal, remember the double equals is not assignment, but it's evaluation, equals to 0, then we have another indentation suite. Then we're going to print I, or we're going to print, excuse me, the number. So let's take a look. If 12 modulus 2 is equal to 0, essentially, that's asking, is this number an even number? Because only even numbers with a modulus 2 will result in a 0. So if 12 modulus 2 equals 0, if this is true, then drop down and do whatever's in this indentation suite. If not, then pop back out. So let's see. 12 modulus 2 equals 0. That's true. Yep. Okay. We're going to print I, which is 12. Boom. Let's put a 12 off to the side. We're printing that out to standard output. Now we pop back up. But when we pop back up, we iterate 1 over. If 15 modulus 2 is equal to 0, well, that's false, so we don't even have to consider this. All right, pop back up. 176. I is now 176. If 176 modulus 2 is equal to 0, yep, okay. Let's go down. It's true. Print. Oh, we're printing 176. So a couple iterations of this, and you can see, bing, this is an even number, it's getting printed. False, we're not printing 15. Bing, printing, not printing, not printing, printing, printing. Oh, we're printing all the even numbers to standard output. That's what this for loop is doing. It's looking at all of the numbers, all the elements within this list, and if it's an even number, we're just going to print them out standard output. Well, that's pretty cool. That's easy. You know, that might be difficult to do for us on paper, but something computers do is repetition very well. And our Python code would rip through this. Doesn't matter if this is a million numbers long or just the 10 numbers that we got here. It would go through and print them out. No big deal. Now, what I want you to do is I want you to take this a step further. On your own, I want you to find a way to print that's odd if the number is odd. See if you can do that. All right. And then if you want to get super fancy, epic, uber developer, Python to the max, I want you to make a running tally of how many even numbers are in the nums list and then print that. Go ahead and kick some code, have fun with it, and then we'll talk about it in a second. All right, boom, baby. Here we go. Let's take a look at what our first task was. We wanted to go through each item in the list, and if it was even, print it like we did. And if it was not even, we wanted to print, well, that's odd. All right, well, that is not too difficult. Let's take this line by line. Ignore the comments because we're gonna get down to that in a second. But we've got our nums list already set. We're done. That's good. We've got a for loop. All right. And this is the cool thing about for loops. If you want to change the mechanism, if you want to increase or scale the functionality of this loop, all you need to do is find out what you know, what parameters, what scenarios would make this thing kick off and be true and happen, and then add it in there. You don't have to do this for each individual element. We just do it once for the lists with the parameters that we have in mind. So let's take a look. We are in the for loop. If it's even, we're printing I, and it's an if statement already. So we know if it's doing this, it's if it's true, if it's even, we're going to print it out. And we can simply add an else statement to that. So if this is true, go here, but if not, if else it's not true, here's our else statement, simply print that's odd. Let's open up a REPL and see what we get. All right, it's going through each item in the list. If it's even, it's going to print that sentry out. If not, if that's not true, it's just going to print out that's odd. And boom, look at what we did. We've gone through each and every item in the list, and if it's even, we print it out. If not, we've printed that's odd. All right, so let's take a look at our other action that we're trying to do. We want to count the number of evens. This is a little funky, but we can do it. It just takes a little bit of setup. First, essentially what we need to do is we need to have a placeholder for our tallies. So I created a variable called evens count, and I initialize it at the number 0. Okay, we're starting with nothing in our evens count. And then, again, the power of the for loop. All we need to do is add a change to the parameters if something is true, right? Because we only want to do something if the number is true. We want to count how many even numbers we have. So that can be done in just a handful of statements. The first is to increase the evens count integer by 1 each time something true, or excuse me, each time something is even, and that's true. So let's just do this. Evens count plus equals, which is short for evens count plus evens, or equals to evens count plus 1. That's a little confusing. I'll write it out. This statement up here is shorthand for this right here. So we don't need this. We're just saying every time that this is true, we're going to take the evens count and we're going to add 1 to it. Okay, so that's good. And then all we need to do is feed that back to the user so that they can see it. So what I'm going to do here is I'm going to put this little line, this bar of equals, just so we have a little separator here. And then I'm going to use an F print to say there are, and then tell me the number that evens count is equal to evens. So I want to point out something. These are both outside of the for loop. If I had left them indented, this would show up every time that the for loop iterated. Let's run this as it is. All right. So it's going through. That's even, that's odd, that's even, that's odd, and there are 5 evens. Had I left this indented, it would give us this every time we ran. And that's really confusing. Like, okay, so here's the 12, and there's 1 even in the evens. Okay, the next one is odd. Next one. See how it's just really confusing? The indentation loop, anything that's, or excuse me, the indentation suite, anything that's in the indentation suite is going to run every time through the loop. If you want something to finalize or conclude at the end of a loop, then you move it out of the indentation suite back to this root margin, and there you go, you're done. Let's clear our terminal, run it again. And now we get the expected output. It's going through the entire list, indicating if it's even or odd. And then at the end, we got a little nice break here for visibility. And it says, oh, we've counted 5 evens. Let's see if that's true. 1, 2, 3, 4, and 5. We're done. Good job, guys. All right, I will see you in the next video where we talk about a couple of new keywords, break and continue. Have a good one.